Okay, so today's notes are on factoring when we have an a value that is not equal to 1. So, or plus or minus 1, if we're being technical. So we're going to jump right in by talking about or doing an example with what is sometimes called the middle term splitting method. Not everyone calls it that, but I think it's a helpful way to remember the process that we will follow. So the example we're going to try this out with asks us to factor 2x squared plus 11x plus 12. So what we're going to do first is check for common factors. Since 2, 11, and 12 do not have any common factors, 11 is actually prime, we won't pull anything out to the front or we won't factor anything out. So then step 2, we're going to identify A, B, and C. So in this problem, A we see is 2 because it's the coefficient of x squared. B, the coefficient of x is 11, and C, our constant, is 12. So A, B, and C are right there. Next thing we're going to do is calculate A times C. So AC is going to be equal to 2 times 12, which gives us 24. So we're fine. Now this is just like what we were doing and when factoring when A is equal to 1. We're finding factors of AC, because previously A was only 1, so we just worried about C. But we're finding factors of A times C that add to B. So this is actually the same thing we did when A was 1, but it was just our C value, since 1 times C would just be C. So now we're going to do the same thing we did in those other examples and find factors of AC that sum to B. So find factors of AC that sum to B. So when I do that, factors of 24 that add to 11. So if we're going to go in order, I have 1 and 24. They're both positive, so I don't need to worry about my negative signs. I have 2 and 12. I have 3 and 8. And that one works. So 3 and 8 will work. And next thing I'm going to do, so step 5, I'm going to rewrite my quadratic or my expression with the middle term split. And it's going to be split into my two factors. So now I have 2x squared plus 3x plus 8x plus 12. So if you see here, I just took my two factors and I split my middle term 11 into these two. So 3x plus 8x is 11x, but I have split it into 2. That's why it's called the middle term splitting method. So I split my middle term into 2. And what I'm going to do with that is group my first two terms and last two terms. So I'm going to group these two and these two, and then I'm going to pull out the greatest common factor. So 7, factor out greatest common factor from each grouping. So when I do that, 2x squared and 3x, I can take an x out of each of them. And when I do that, I'm left with 2x plus 3. Here, I can't take an x, but both the 8 and 12 are divisible by 4. So I'm going to take out a positive 4, and I'm left with 2x plus 3. And wouldn't you know it, I found a common factor of those two terms, x and 4, that I can now pull to the front. And I will take my other term, and wouldn't you know it, there's our factored form. So the two terms that the 2x plus 3 is our common factor, and we pull that to the front, and then we have x plus 4 as our second term, or a second binomial that we are multiplying by. So to break down the steps, for when we pull out our greatest common factor, the terms in parentheses must match. So if you notice here, 2x plus 3 and 2x plus 3, they're the same thing. So they must be equal is another way to say this. So I can't pull out a greatest common factor of 2x plus 3 unless they are in fact the same term or same binomial. So you have to make sure that these two terms match if you're going to pull them to the front. And then I bring that step 8 was bring binomial to the front, just like we did with our greatest common factor. It actually doesn't technically matter which order you write it in, but just out of habit, the same thing we did with greatest common factor was pull it to the front. So that's what I'm continuing to do here, though you could write this in either order. It doesn't really matter. And last but not least, we're going to check our answer. Again, this is not required, but it is a best practice. So this is our solution at this point, but we can redistribute it to make sure, or use the FOIL method to make sure it gives us the same original trinomial we started with. So when I distribute that, I get 2x squared plus 8x plus 3x plus 12, which when I combine my like terms, indeed gives me the same original trinomial. So that is the middle term splitting method. We are definitely going to do a quick check on that. So I'm going to flip the page for that quick check. So what I want you to do here is factor 4x squared plus 7x plus 3. So pause that one, try it on your own. I'm going to go over it now. So I'm going to start by, I don't have any common factors. 7 and 3 are both prime, so I can't pull out a greatest common factor. So I'm going to identify my a, b, and c values. And I'm going to find a times c, which is 4 times 3, which gives me 12. So I'm going to find factors of 12 that sum to 7. They're both positive, so I don't need to worry about negative signs. So 1 and 12, 2 and 6, 3 and 4, that will give me 7. So that's going to be the terms I split that into. So I'm going to move this up here. I have 4x squared. I'm splitting my middle term into 3x and 4x, and then I have the 3 there. And then I'm going to group them. Again, if you had these in a different order, you still should end up with the same answer, but we'll get there in a second. So here the common factor is x, and I'm left with 4x plus 3. Here, there's no common factor, so I just leave plus 1, and I get 4x plus 3. So if you notice, it's a little bit different than what we had previously. There's nothing I can factor out here, but that means there's still a 1 there. So when I rewrite this, I bring my 4x plus 3 to the front, and then x plus 1 is my second term, and there's my answer. I can check it for good measure, so when I redistribute, I get 4x squared plus 4x plus 3x plus 3. I combine my like terms, and I get, I'm going to write it over here for the sake of space, 4x squared plus 7x plus 3, which is indeed the original trinomial we started with, so we have solved that correctly. All right, we're going to do another example with some negatives just so we can see what that will look like with the middle term splitting method. So our last example together, I'm going to ask, we're going to factor 4x squared minus 4x minus 3. So again, start the same way, check for common factors. There aren't any, so determine a, b, and c. I'm not going to write this one this time. So 4 is a, b is -4, c is -3. So once I do that, I find factors of a, c that sum to b. So AC is 4 times -3, which will give us -12. And I'm finding factors of -12 that add to -4. So that means my greater factor will be negative. So I have positive 1 and negative 12. I have positive 2 and negative 6. And wouldn't you know it, that one will add to negative 4. So those will be my two middle terms when I split my middle term that I currently have. So I'm going to rewrite with the middle term split. And when I do that, I'm left with 4x squared plus 2x minus 6x minus 3. So this is again the same process. We're just adding some negatives in to make it a little bit different looking. But I'm going to do the same steps, group terms. So I'm going to group these terms and those terms. And I'm going to find my greatest common factor for each pair. So here, 4x squared and 2x, I can bring a 2x to the front, which leaves me with 2x plus 1 in there. And here, they both are negative, so I can take out a negative, and then they're both divisible by 3. So I'll say negative 3, and that leaves me with 2x plus 1 again. So that works. I bring my common factors to the front and bring my other terms there, and I'm left with 2x plus 1 times 2x minus 3. And that should be my correct factored form for good measure. So for 5, bring greatest common factor to the front. Again, it doesn't necessarily matter the order in which you write them. I'm just doing that out of habit and consistency. So then for good measure, we can check our answer. So I redistribute and I get 4x squared minus 6x plus 2x minus 3, which gives me 4x squared minus 4x minus 3, which is our original trinomial. So our factored form is indeed correct. Okay, we're going to do one more quick check because I know this is tricky and I want to make sure you guys get plenty of practice. I want you to factor 2x squared minus 7x plus 6. Pause it, try it on your own, make sure you're understanding this. I'm going to go over it now. So A here is 2, B is negative 7, C is 6. So I'm going to find factors of AC, which is factors of 2 times 6, which is 12. So I'm finding factors of 12 that add to negative 7. So again, my larger factor is going to be negative here. Both factors are going to be negative because they're adding to a negative but multiplying to a positive. So both my terms will be negative here. So I could have negative 1 and negative 12, which does not work. Negative 2 and negative 6 does not work. Negative 3 and negative 4, those do add to negative 7. So those will be my two terms. So then I'm going to rewrite my quadratic expression with my middle term split into negative 3x and negative 4x plus 6. I group my terms. Here I can pull out a x, so I'm left with 2x minus 3. Here I can pull out a negative 2, so that because I want this to be a positive first term, so I pull out a negative 2. I'm left with 2x minus 3 again, so those match. I can bring them to the front, 2x minus 3, and then x minus 2. So my answer, I'm going to rewrite it here, 2x minus 3, x minus 2 is my factored form, but for good measure, I will check it. So I get 2x squared minus 4x minus 3x plus 6. Combine my like terms, and I get 2x squared minus 7x plus 6, which matches my original expression, so my factored form is indeed correct. All right, I know this is pretty tricky, so make sure you write down any questions, comments, concerns you have so we can go over it together in class.